Alright, so section 3 of chapter 10, we're learning about ellipses today, which, to you probably just look like ovals, but the technical name for them is an ellipse. So the definition for an ellipse is a set of all points P on a plane, so we're talking about all the points on the ellipse, that the sum of the distances from any of those points, so like a point P, on the ellipse to two fixed points called the foci, is the constant sum of the two distances. So basically what it's saying is any point on this ellipse, if you add the distances from the two foci, that's going to be the same value no matter what point you have on the ellipse. So with that in mind, if we want to find that constant sum for an ellipse, so when we're finding the constant sum, again, we're finding, okay, what do we get when we add these two lengths up? So what we got to do when we have our two foci and our point on our circle is figure out the distances. So kind of using this equation, well, we are using this equation, distance from F1 to P plus the distance of F2, the other focus, to P as well. So distance from F1 to P, so 0, -8 to 0, 10. Okay, since they both start with a 0, it's easy to see that they're 18 apart when you look at the -8 and the 10. So 18 plus, and then comparing these two, 0, 8 is 2 away from 0, 10, so that constant sum would be 20. The next example, not quite as easy to see because they don't share any of these numbers here. So first, to find F1 to P, we need to use distance formula. So looking at this point here and this point here, we got 3 minus 9 squared plus 0 minus 8 squared. So then that's going to equal -6 squared is 36, and then 8 squared is 64, so square root of 100, which equals 10. So that's the first one. And then when we do F2 to P, okay, so now we're finding the distance between these two. So square root 24 minus 9 squared, and then 0 minus 8 squared. You got the plus there, so simplifying that. 24 minus 9 is 15. 15 squared is 225 plus 64. So that would be square root of 289, which is 17. So when we add those, our constant sum is going to be 27 there. So finding constant sum, basically you're just finding two distances and adding them up. So now when you look at an actual ellipse, there's lots of parts to it. So you'll notice we got these foci, which I just talked about. We have a center, just like we do in a circle. Now we don't have a radius because, we're not the same distance from the center every time. But we do have vertices. So vertices are going to be the farthest points away from the center. Okay. The covertices go the other direction. Okay. So here, these two are covertices. We got our vertices here and here. And then the foci always line up with those vertices as well. So they're on the same axis. So those will always lie on the major axis. On the minor axis is always the covertices. And you'll notice we use A, B, and C for those. So A refers to the vertex, B covertex, C focus. Okay, so this is what we call a horizontal ellipse. Here we have a vertical one. So in this case, your vertices are actually at the top and bottom on this one. Again, the vertices are the farthest from the center. Okay, so obviously your center is here. B's would be the covertices. Same thing here. And then again, the foci always line up with the vertex. So this would be a focus here. This would be a focus here. Okay. If you're confused, foci is just the plural form of focus. So the vertices can be either vertical or horizontal. Just depends on the kind of ellipse you're dealing with. So now we get into equations for an ellipse. So these equations are only when your center is at 0, 0. Okay. We'll talk about what happens when your center isn't at 0, 0 as we go a little farther. So it's kind of like the equation of a circle. You got an x squared plus a y squared equals 1. However, you have these values on the bottom, the a and the b. Now notice there's two different equations. One where a is with x, one where b is with x. So it all depends on the type of ellipse you have. So on a horizontal ellipse, okay, that means your a's, your vertices, go horizontally. Okay, so that's why here the vertices are with x. If it's vertical, your vertices have to go with y. The a needs to go with y. So that's the difference there. So again, we just got a picture of an ellipse here. So in this one, it's horizontal. So our vertices are here and here, co-vertices here and here, foci here and here. We're going to use a little Pythagorean theorem as well, because just like in Pythagorean theorem, okay, we got a squared plus b squared equals c squared, right? Well, if you look at our diagram here, the a is actually the hypotenuse. So really, we're going to use a squared minus b squared equals c squared. So let's go ahead and try to write the equation for an ellipse over here. So again, center's at 0, 0. Okay, so we know if it's at 0, 0, we have x squared, and we're going to have y squared, and it's going to equal 1. Okay, now the vertices, 6, 0. So that's going to the right 6 from 0, 0. So that means that we're 6 away. So a has a value of 6. So 6 squared. The co-vertices are going up and down, so that's why they go with y. 0, 4 is up 4 from 0, 0. So since it's up 4, it'll be 4 squared. Okay, so all the way simplified, we'd have x squared over 36 plus y squared over 16 equals 1 for our equation. All right, the next one, we're only given the co-vertices and the focus, okay, or co-vertex and a focus. We need to figure out where our vertex is. So we're going to go back to this equation here. So a squared minus b squared equals c squared. So remember the vertex is a, right? So we would have a squared minus b co-vertices. So that's 5 away from 0, 0. So minus 5 squared equals c squared, and c is your focus. So 3 squared. So a squared is going to equal, let's add 25 to both sides because 5 squared is 25. 9 here, so 9 plus 25 is 34. So a is the square root of 34. Now we can write our equation. I'm going to write it over here. So square root of 34, okay, that's bigger than 5, obviously, right? And since our co-vertex is going left and right, 5, 0 is 5 to the right is 0, 0, this could be going up and down square root of 34. So think of it as you have a point at 0, 34, and 0, negative square root of 34. Okay, so now let's write our equation. So since these are going vertically, so again, we'll start with x squared plus y squared equals 1. So the vertices are here. So they need to go under y. So square root of 34 squared is 34. And then the co-vertices are going left and right, so they go with x. 5 squared is 25. So that's the equation for the ellipse there. Okay, now when your center isn't at 0, 0, the equations are the same except for now we have h and k. Okay, they just represent where your center is, just like in a circle. So it says to graph these, so this will be interesting. I'm trying to write on my little pad here. Let's go ahead and try. So remember, HK is the center, right? So our center here is at 2 and 4. So center, let's go to 2. Let's go to 4. So here's our center here. Okay, now we got to find our vertices and co-vertices. So let's just start with x, right? So we have 25, okay? The square root of that is 5. So we need to go from our center, right 5, and put a point. And then left 5, Okay. And then from y, or going up and down, square root of 9 is 3. So we would go up 3. Oops, I should use a different color there. Up 3 from the center, and down 3 from the center. So again, I apologize, my ellipse is probably going to look really gross. Oops, kind of missed that point, but you get what I'm doing here. So if you're wondering which ones are the vertices, okay, the vertices are these two, right? So the vertices, and you'll have to do this on your assignment, are at 7, 4 there, and negative 4, 4. I counted right, I think I did. Oh, nope, this point actually is supposed to be right there. So my ellipse should have been like that. Okay, so that would be negative 3, 4. I need to get my eyes checked, apparently. Okay, and then our covertices. Those are these 2 points. So we're at 2, 7, and 2, 1. Okay, if you need to find the foci, which you will on your assignment, remember that's a squared minus b squared equals c squared. So remember a, that's our vertices, so that was 5 squared minus covertices were 3 apart, so equals c squared. So 25 minus 9 is 16, so c has a value of 4, so that means they're 4 away. So the covertices, remember they line up with the vertices, are 4 away. So they would be here and here, 4 from the center. So those would be at negative 2, 4 and 6, 4. And that's where those are at. Okay, so just so you know how to find those things. Okay, now if we wanted to graph this one, start with the center. So it looks like we have negative 3 and 0. So negative 3, 0, here's our center. Vertices, they're farther, so they're obviously going up and down, right? Square root of 81 is 9, so we go up 9 from there, and down 9. And then 7 for the covertices. So that would be here and here. So again, I'm going to try to graph this. Yikes. This is a lot harder than it looks. Alright, hopefully your graphs look better than my deformed eggs here. Okay, and then again, the vertices, if you're wondering where those are at, a squared, so 81, minus 49 equals your c squared. So that would be 32. So c would be square root of 32, right? So that's just a little bit less than 6. So your covertices, again, line up with your vertices. So your covertices would be, let's see, a little bit less than 6. So yeah, somewhere right there and somewhere right here. Okay. And if you're writing them, you could write a point at you know, negative 3 square root of 32, okay, or 4 root 2, I guess it would be. All right. I'm going to do a couple more examples in the second video, because this video is almost up for the 15 minutes. So I'm going to go ahead and pause this one, start a new one.